Hello, this is a video on molarity, molality, and mole fraction. These are all units of concentration, and we get a lot of questions at the RVCC Tutoring Center about how to interconvert those two. So I wanted to start with just talking about what the three different ways to express concentration are, and then we'll take a look at an example. So the first one that we see a lot is molarity, and it's expressed with this big M, and it's our moles of solvent of solute per liter of solution. Okay, this is very convenient when we're doing stoichiometry and doing calculations in the lab. However, our liters of solution is going to be temperature dependent, so we have to be careful with that. There's two other ways to express concentration that are not temperature dependent, and the first is the mole fraction. We have moles of A, so moles of one component of our solution divided by the total moles of all components. So we have to calculate the moles of both things in order to calculate that mole fraction. The final way to express our concentration is molality. It's this little m, and it's moles of solute per kilogram of solvent. So again, this is useful if you want something that's temperature independent, but it's going to it's not as common a unit to work with. Okay, so when we look at interconverting these, I always write down what they mean. Like if given something in molarity, I wrote moles per liter. And if I have something in molality, I'll put moles per kilogram of solvent, so that we see these symbols. You should start to automatically think about what they mean and what that means in terms of your calculation. Okay, so I'm going to take a look. I have in here an example. So we have nitric acid. This is an example from your textbook. Nitric acid, HNO3, is commercially available as a 3.7 molal solution with a density of 1.35 grams per milliliter. What is the molarity of the solution? So the first thing that I always do is I'm going to write, this is, oops, I have to annotate. Hold on just a minute. The first thing that I want to do is I want to write down this 33.7. This is our little m. So we said our little m is our moles HNO3 per 1 kilogram of water. Okay. So in all of these things, it's very useful to make an assumption. Okay. So when you're given, and your assumptions are going to be determined on whatever you're given. In this case, I'm going to assume one kilogram of water. So we have a solution, it's a kilogram of water. Okay, if that's the case, then we have 33.7 moles of nitric acid. Okay, so we want to ultimately get to molality over here. And this molality, again, this is moles per liter of our solution, right? So we're given our density is grams per milliliter. So what we're going to do when we attack this problem is I'm going to calculate the total weight of my solution. Then we can calculate the milliliters of our solution, and with using our density. And then finally, we can calculate the molarity of our solution. Okay, so if we have 33.7 moles of nitric acid, we can find out the weight of this. We're simply going to multiply this by the molecular weight, which is 63.01 grams per mole. Okay, so our moles are going to cancel out. This gives us 2,123 grams. Okay, so that's the grams of our nitric acid. But remember, this is a solution, and we assumed that we had 1 kilogram of water. So a kilogram is 1,000 grams. This should be, you should remember this from Chem 103 to do that. If you need help on that, I'm actually going to be making a separate set of videos on that, so you can go back and take a look at that. But we have 1,000 grams of water and 2,123 grams of nitric acid. So our total, we have 3,123 grams of solution. Okay. Now we can use our density to calculate the volume of that solution. So we're going to multiply this times, this is 1 milliliter per 1.35 grams. Okay, when we do that calculation, we get 2,313 milliliters. And that's of our solution. Okay, I'm going to convert this to liters. I'm going to move my decimal place. This is equal to 2.313 liters. Decimal place is there. Okay, so now I'm looking for moles per liter. I know how many liters I have. So I have 2.313 liters. And I know how many moles I had. We started with that. We had 33.7 moles. So when we calculate this out, this calculates to 14.6. I'm rounding to 3 sig figs because I had 3 sig figs in both my molality and my density. Okay, so this is my final answer. So again, what we want to do is, if we're not quite sure what to do at start, we can make an assumption. In this case, we assumed we had 1 kilogram of water. We calculated the weight of our nitric acid based on that. We found our total weight. We used that weight to find our density. And then we were able to calculate our molarity. So if you need more help on these types of problems, I'm going to put together another video with a couple more examples. But the tutors at the Raritan Valley Community College Tutoring Center are here to help the Raritan Valley Community College students. You can schedule an appointment through academia. If you found this video, you've probably found our YouTube channel, and you can just search appointment in there, and you'll find a video instructions on scheduling appointments. The link is directly here if you want to copy that down. And finally, I just wanted to thank the slide template is by Carnival Slides, and the content in the example were from your textbook, which is Chemistry Adams First, the second edition. And it's available through our library. There's a link to the OpenStax link to this book.